Today and the incoming few videos, we will be talking about polynomials. But first we will talk about important concepts like constant and variables. Why do we need to understand about these two terms is because each and every polynomial is made up of constant and variables. So it is very important that we should have basic understanding about the two. So constants. Anything whose value doesn't change during the course of problem is called a constant. Okay, so let me take an example. Suppose we have rupees 100 and we need to buy oranges. So here we can say that rupees 100 is a fixed value. That is, its value doesn't change. So rupees 100 is a constant. Now we have few examples. 2 being the positive, minus 2 negative, 0.2 being a decimal term, 1 by 2 being a fraction, and root 2 being irrational, all are considered as constants. Now variables. Anything whose value may change during the course of problem is called a variable. Looking at the previous example, we have oranges to be bought. So oranges are bought by per kg price. Now since the sizes of oranges can be different, so any number of oranges can be bought in rupees 100. So here oranges, the value of oranges is not fixed. So oranges are variable. Now x, y, z, t and s are all variables. That is, the value of these x, y, z can be changed during the course of problem. Okay. So now introduction to polynomials, that is monomials. Now polynomials are made of monomials and monomials are made of constant and variables. Therefore monomial is a very important term and needs to be understood. Okay, so monomial. If you look closer to the term monomial, it consists of the word mono, which means single or one. So basically what is a monomial? It is a single term expression having product of constant and variable, and power of variable should be a whole number. Okay, so now we have three conditions, like it has to be a single term expression having product of constant and variable. Then we have that the power of the variable in the monomial has to be a whole number. So we see that single term expression is the condition 1, product of constant and variable is the condition 2, and power of variable should be a whole number is the condition 3. Now let me take an example in order that we understand the concept of monomial in a better way. So we have 2x to the power 4. So this is given. So we need to prove all the three conditions in order to show that 2x to the power 4 is a monomial. Okay, so we have the first condition to be as single term expression. So we see that 2x to the power 4, yes, it is a single term expression as it doesn't have any other term. So condition first is satisfied. Okay, moving on to the second condition, we see that 2 is a constant term. Okay, x is the variable term, and these two are being multiplied. So we can say that 2x to the power 4 is a product of constant and variable. So condition 2 is satisfied. Now power of variable should be a whole number. So we see that the power of the whole number is 4. Now what are whole numbers? So whole numbers are 0 and all the natural numbers. So 0, 1, 2, 3, 200, 200 and so on, all are whole numbers. So here we see that 4 is a whole number. So condition 3 is also being satisfied. And since all the three conditions are satisfied, so we can say that 2x to the power 4 is a monomial. Now we have a general form of monomial that is equal to constant into variable to the power of whole number. Now we can compare this with the above given example that we have taken, 2x to the power 4. So here we can say is that the constant here is 2, variable here is x, and the whole number here is 4. Okay, so this is a general form of monomial. Now let us do some examples in order to understand the concept of monomials. The first example is minus 3x square. Okay, so we need to prove that is this a monomial or not. So we have three conditions to be proven. Only then we can say that it is a monomial. So we see that yes, it is a single term expression as it has only one term. Moving on to the second condition, we have product of constant and variable. So here 3 is the constant, x is the variable, and they two are being multiplied. So yes, the second term is also being satisfied. Now the whole number part. So we see that it has x square. 2, yes, being a whole number. So we can say that yes, the third condition is also being satisfied. Since all the three conditions are being satisfied, so we can say that yes, minus 3x square is a monomial. Moving on to the next example, we have 3x to the power 0.6. The first condition is single term expression. Yes, it is a single term expression. It has a single term. The second condition is product of constant and variable. So 3 being the constant, x being a variable. So the condition 2 is also being satisfied. Now x has a power of 0.6. But 0.6 is not a whole number. So we can say that the condition 3 is not being satisfied. Since one condition is not valid, so all the three conditions has to be satisfied for monomial. So we can say that 3x to the power 0.6 is not a monomial. Next question, 3 plus x square. So looking at to the first condition, we have 3 plus x square. We see that 3 plus x square is not a single term expression as it has two terms, 3 and x square. So the condition 1 is not satisfied. Since all the three conditions have to be satisfied, so we can already say that 3 plus x square is not a monomial. The fourth question, minus 0.4 x square y to the power 5. Now this question is different from the above three examples because it has two variables. So in this we need to check the conditions of both the variables, that is x and y. So we have x as the variable 1 and y being the variable 2. Now checking the first condition, we have minus 0.4 x square y to the power 5. Yes, it is a single term expression as it has only one term. It is a single term. So condition 1 is satisfied. Now product of constant and variable. So here 0.4 is a constant, x and y being the variable, and they are being multiplied. So we can say that yes, it is a product of constant and variable. So condition 2 is satisfied. Now whole number power. So first we'll check for variable 1, that is x. So it has a power of 2, and variable 2, that is y, has a power of 5. Since both 2 and 5 are whole numbers, so we can say that yes, the condition 3 is also satisfied. So we see that all the conditions are satisfied. So minus 0.4 x square y to the power 5 is a monomial. Now the question that arises is that is constant a monomial? So we take an example. Suppose we have 7. So now we can say that since 7 doesn't have a variable in it, so we can already say that no, it is not a monomial, since monomial has to contain a variable. So what we can do is 7 can be written as 7 into 1, and 1 can be written in anything raised to the power 0. So it can be written as x to the power 0 or y to the power 0 or anything. Since 1 to the power 0 is equal to 1, 2 raised to the power 0 is 1, 5 to the power 0 is 1. So anything raised to the power 0 is 1. So what we can do is we can write 7 as 7 into x to the power 0. Now we can check if it satisfied the condition of monomial. So we see that 7x to the power 0, it is a single term expression. So we can say that the condition 1 is satisfied. Moving on to the second condition, we have 7 and x, that is constant and variable, and it is being multiplied. So yes, condition 2 is satisfied. Condition 3, the power of the variable is 0, which is a whole number.
So we can say that the condition 3 is also satisfied. Thus, we can conclude that 7 is a monomial. Okay, so in general, we can write as all non-zero constants are monomials. This is the generalized form for any constant. So 3, 4, 5, they all are monomials, since they can be written as 3y to the power 0, 4s to the power 0, or 5 can be written as 5z to the power 0. So all of them are monomials.